again. A satellite. Just to remind ourselves, a satellite is any object that orbits another object. And artificial satellites are those that are man-made and are launched into space then. Geostationary satellites are a particular kind of satellite, and these are ones which stay above the same point on Earth at all times. The speed of the orbit of that satellite matches the Earth's rotation. So orbit time for any geostationary orbit satellite is 24 hours. These satellites are used for applications such as communications, satellite TV, weather forecasting, intelligence, and global positioning, or GPS. There is another kind of polar orbit satellite, which, whilst you should be aware of it, you don't need to learn about, but it's called a polar orbit satellite. And these ones orbit from pole to pole, so they're a completely different direction of orbit. And these are used for large-scale mapping and global weather monitoring. Just out of interest, the satellites that have been launched into space and are geostationary can produce images such as this of the Earth. We can also use satellites then to view space. So as well as looking down on Earth, we can use them to view out into space. Astronomical satellites, such as the Hubble Space Telescope, are large telescopes placed in a high orbit, far from the effects of the Earth's atmosphere. These satellites can see much further into space and give us images of stars and galaxies many light years away, something like this Cartwheel galaxy. So whilst we send satellites into orbit, we don't just abandon them. We have to be able to repair them and maintain them. Meteorites, the solar wind and space junk all travel very quickly through space and can damage satellites. Therefore, astronauts need to be able to spacewalk in order to fix them. In order to support satellites and other investigations in space, we have what's called the International Space Station. This is a permanently manned floating laboratory in space that orbits at 400 kilometres above the Earth's surface at a speed of approximately 28,000 kilometres per hour. The speed of orbit is very important because if it's too slow, the space station will fall back to Earth again. And if it's too fast, it will spin off into space. This is true for all satellites. Space travel then. Space travel is only limited by time. If we were to try and travel to Pluto, it would take us about 84 years. In other words, a human lifetime. And if we wanted to reach the nearest star to us, Alpha Centauri, this would take us about 40,000 years. And finally, to finish off then, is there anybody out there? Given the vast size of the universe, it is entirely possible that life exists on another planet similar to ours, somewhere in the solar system. However, given how long it would take to get to our nearest star, the chances of finding this particular planet are very slim. This concludes Videocast 3. You can now answer the questions on the worksheet either provided to you by the teacher or which you can download from the intranet site. Thank you for your attention.